Hi, welcome to the Shiko Math Lab differential equation problem solving section. So today we are going to solve a pretty easy differential equation. So here's the problem. It's y prime equal to y and ex sine x, y0 equal to 1. Okay, so that's the initial value. All right, let's take a look find the strategy we're going to use to approach this problem here. The first thing is like I always mention in my previous videos, and so the first thing we observed here. All right, so it seems like here this is a function of the x, this is a function of the x. So it's all the function of the x by itself. All right, there's no y part of it. So let's go to sign. Then we see the y value, y here, y is by itself here also. That's good. So we know if you have a function y and a function x, if they are total just by themselves, that will be a very good candidate to do the variable separation. So let's do it one more time. See here, the variable separation to see how easy this one is. So like I said, I always like to change the y prime. So the dy dx, so I can see easily. So this is ex sine x. So this one is pretty easy to do the variable separation. Move all the y to the one side, x to the other side. So in here, I move the y over, I have dy over y is equal to the ex sine x dx. Wow, that's pretty good. So now let's try to integrate both sides, right? So after the variable separation, then we can integrate both sides here. Okay, so let's make it easier. So integrate both sides. Okay. So the left-hand side, when I integrate, I will have what? I will have the natural log of y is right equal. So let me, just like we always did, let me kind of highlight this is my result on the left-hand side. Now, let's take a look. How do we do this ones here? So this is the ex sine x dx. If you still remember in your calculus 2 integration, this has to be done by parts, right? So integrate by parts. And because this is like the exponential and the trig function combination, so instead of just doing the typical by part uv minus vdu, I think most of your teachers show you how to do the tabular methods here. All right, so let's do a tabular methods here. So this is my ex. So this column, this is want to take the derivative. Remember that? And this one we want to do the integration. Right, that's what we talk about the tabular methods here. Okay, so now this is ex. Then we know the ex, the derivative is all the same. Okay, so this is a sine x. The integration of the sine x is negative cosine x. All right. Then the negative cosine x, the integration will be negative sine x. So this is the place we will stop because we find out, oh my gosh, this column I always going to repeat, will be never end, right? So that's why we say, okay, we stop at here. Okay, so let's, all right, so we say, okay, let's stop at here. Okay. Okay, then I don't know, you guys remember or not, when we do the tabular method, after you do this, what is the next things here? You do plus, minus, plus, right? Plus, minus, plus. Okay, so then what you do here, after you did that, so you do here, right? And here, right? Okay, so now let's take a look. So this one's here. Let me go here, have a little bit more space. So this is the ex sine x dx is equal to, so plus minus, all right? So the plus minus, what is this one's here? This is minus ex sine x. I'm sorry, sine cosine x. Sorry here. So this will be negative ex cosine x. All right. And then this line, negative is a positive, right? So it's a plus ex sine x. Okay, so remember we need to stop here, right? Because it is never ending. So this is plus minus, so it's a minus. This is the ex sine x. This is dx. So this is what this brown the circles here. All right, so now in here we see this is a minus ex sine x, this is positive. So I add the ex sine x dx both sides. I add ex sine x dx both sides. This is what we did the tabular method. So here, what do we have here? We have 2 ex sine x dx equal negative ex. I can, well, if I like, I can factor, I guess I can factor the ex out, right? Maybe. So if I factor the ex out, I will get the sine x minus cosine x. So finally, my ex sine x dx is going to be equal to the e to the x over 2, right? And then this is sine x minus cosine x here. All right, so this is going to be sine x minus cosine x. All right. Okay, plus, of course, all this going to be a plus c here. All right, so now let me put this one back to here. So this is 2 to the ex and sine x minus cosine x plus c. All right, okay, now I can substitute my initial value. My initial value is 1, 0, y0 equal to 1. y0 equal to 1, so I substitute my initial values here. So make sure okay, so y0 equal to 1, so y equal to 1. So this is a natural log 1, and then this is 2 to the e0 sine 0 minus cosine 0 plus c. So this is equal to 0, and sine 0 equal to 0, cosine 0 equal to 1. So it's equal to the negative 1/2 plus c, right? So now finally I got my c equal to what? 1/2. All right, so now I can write it. So natural log y, okay. So the natural log y is equal to 2 to the ex over 2, and sine x minus cosine x, sine x minus cosine x plus 1/2. Then I take the exponential both sides. All right, so take the exponential both sides, and so the natural log y. So if I do the exponential, so y, because I can get rid of absolute value because this is positive, right? So this is e to the ex over 2 sine x minus cosine x times 1/2 here. No, plus 1/2 here, right? So if you want, you can take this e to the 1/2 out, then times e to the x over 2 sine x minus cosine x. All right, that's it. So this is the solution for this problem. So this problem, the it's pretty easy problem by the separation variable. But I guess the things that might get you is if you don't remember the integrated by part, then might make you struggle a little bit. So you might want to review this integration by part here. All right, but especially the tabular method, to me, I think it's a pretty easy method to use. All right, that's it. That's for today. And I'm glad you'll be able to, we'll be able to work on this problem and kind of use this problem to review some of our integration skill. All right, you have a nice day, and I will talk to you later. Okay, bye. And we're going to work on some more interesting problem, maybe a little bit more challenging problem later. Okay, talk to you later. Okay, bye bye.